Hello students, today I'm going to teach you how to verify Cayley-Hamilton theorem. This topic will come under matrices. Very easy, very simple. Using the calculator, I'm going to simplify this Cayley-Hamilton theorem. We just see what is the statement and we use the verification how we are going to verify Cayley-Hamilton theorem. Welcome you students to my YouTube channel, Engineering Mathematics Made Easy for All. This is with trick and using formula and using calculator directly we get the answer. Students, we'll start now. Yes students, here we have Cayley-Hamilton theorem. So before going to Cayley-Hamilton theorem, we see what is characteristic polynomial. So here I am going to define characteristic polynomial. The determinant mod of a minus lambda is equal to 0 when expanded will give a polynomial which we call as characteristic polynomial. This is very important students. You can see how characteristic polynomial is defined. Here we take 3 cross 3 matrix or 2 cross 2 matrix. We always take the characteristic equation is determined always by mod of a minus lambda I is equal to 0. And then we see, we first take its characteristic equation, can be written as lambda cube minus lambda square plus s2 lambda minus s3 is equal to 0, where s1 is equal to sum of the diagonal elements and s2 is the sum of the minors of the diagonal elements, and s3 is the determinant of a, which is equal to mod of a. So we just see using first and second method. First method is easy. It is directly you take the characteristic equation is determined as mod of a minus lambda I is equal to 0. And second method, we use this formula, that is lambda square minus s1 lambda plus s2 is equal to 0, where s1 is the sum of the diagonal elements and s2 is the determinant of a is equal to mod a. So these two methods I am going to use. So using calculator we are going to find today's example, that is Cayley-Hamilton theorem. What Cayley-Hamilton theorem says students? Please remember, every square matrix satisfies its own characteristic equation. So we just use this characteristic equation for 2 cross 2 matrix, and here we find first characteristic equation, then we go to the verifying Cayley-Hamilton theorem. So this is more important in this. To find first characteristic equation. So here we go with the characteristic equation. Okay. Just go down. So please write down the question students. Verify characteristic equation. So this is, we have the example 1. So very simple example they have given here students. Verify Cayley-Hamilton theorem. So we'll start now. Just I will take the pen. So write down the solution students. First, we see that characteristic equation, this is of order 2 cross 2. Whenever the order 2 cross 2, please remember 2 rows and 2 columns is nothing but the order 2 cross 2. So please write this equation matrix. I'm going to take this as A is equal to 1 minus 2 to 1. I'll write the first characteristic equation. So how we are going to take the characteristic equation, friends? So this will be mod of A minus lambda I. So please take the mod of A minus lambda I. So this will be mod of A minus lambda I is equal to 0. So when you write this characteristic equation, this is characteristic equation. Is it clear, students? Now we'll take the characteristic equation of A is, so I'm going to take this characteristic equation as, because this is 2 cross 2, please remember the formula here shortcut. I'm going to take directly lambda square minus s1 lambda plus s2 is equal to 0. So where s1, just now I have given what is s1, s2, so just I will write it down. So here please remember s1 is nothing but sum of the main diagonal, elements, and this will be equal to, so look on the example, students. What is the diagonal element? You can easily find. In this case we can see that what is diagonal element. Yes, the diagonal element here is 1 and 1. So here I am going to take this as 1 and 1. This is our diagonal element. You can look on the screen, students. This is 1 plus 1 will give you directly 2. So this is our main diagonal element. So next, what is S2? S2 is given by determinant of A. So how you are going to find the determinant of A? Already you have come across what is determinant of A, students. I will just show you how you are going to take the determinant using the calculator. Here I have calculator. So I am going to use this calculator and find its determinant. So you can see only for 2 cross 2 matrix you can easily find the determinant here. So I will take the determinant. So first go to mode setup, then on the right hand side you can see, students, I will go to matrix 6. So then press AC, just follow the steps. First I went to mode setup, then go to 6, it will come your matrix. So you can then press AC, then you will get MAT. If you don't understand, please repeat the video once again. So here you will get MAT, that is a matrix form. So I'll just type here shift, here 4 matrix is written. Above the 4 in yellow line they have written as matrix. So I will just take this as matrix. Then I will go to dimension 1. Then I will press again 1. Then next you can see this is 2 cross 2 matrix. So I will press 5. Now just enter the value, students. This is 1 equal to minus 2 equal to, next is 2 equal to, and this is 1 equal to. So for 2 cross 2 matrix you can do very easily. For 3 cross 3 it will take time. So if you practice this for 2 cross 2, 3 cross 3 will be very easy, students. Okay, so now this is 2 cross 2 matrix I have done. Okay, now then after fitting this for all the values, just press AC, go to again shift, don't change the settings once again, then go to 4, it is matrix, Here you can see determinant is 7 number. Just press 7, shift again 4 matrix. Here it is 3. Close the bracket and just say yes students. On the right hand side you can see very easily it is determinant of matrix A, which is equal to, yes students, it is 5. So directly I would write here we have 5. So S1 S2 is clear now. So whenever you write 2 cross 2 matrix, you have to remember this characteristic equation lambda square. This is plus minus plus, you will get, so lambda 2 lambda square minus S1 lambda plus S2 is equal to 0. So S1 you know 2 and S2 is equal to 5. So therefore what will be the value here students? Therefore you will get here characteristic equation lambda square minus 2 lambda plus 5 is equal to 0. So this is our characteristic equation. Is, just say this as characteristic equation. Now after finding the characteristic equation students, immediately you are going to substitute, or we are going to verify the Cayley-Hamilton theorem. Okay, so now I will take the Cayley-Hamilton theorem. Yes, what I am going to do, I am going to take Cayley-Hamilton theorem to verify. Just I have to prove, I have to prove this letter, that is I am going to take this as lambda square, as wherever lambda is there I am going to take A. So I am going to prove this is A square minus 2A plus 5 is equal to 0. Okay, I am going to prove this. So what I have done, I have just put lambda is equal to E. That's it. Now I have to prove this LHS is equal to RHS students. I have to prove LHS must be equal to RHS. Is it clear students? Okay, let us try now. Again, I am going to use the calculator here. In this case, you will get the value directly. So now, okay, first already you have put matrix A values, right? Am I right? Matrix A value you have already put. Now in the same case, what you are going to do? You are going to take your shift, just a minute. Okay, that's the problem. Okay, take shift. I think my values have gone, so you don't worry. You just put the values, whatever the matrix you have already calculated. So here I am going to take again shift. So here we can see when you off the calculator, this will not show. So again you have to go setup, mode setup you go, then go to matrix. I am repeating this once again. Go to matrix 1. Then this is 2 cross 2 matrix. So I am going to take here 5. Now I am going to substitute the values. 1 equal to minus 2 equal to, and 2 equal to 1 equal to. So now I have fit the A value, press AC, then now just go to shift 4. Now this is matrix A. Here you can see, yes friends, we have matrix A square. Here you can see directly I will take square. Is it clear? So this is equal to, yes, whatever the values we have, I am going to substitute here. So therefore, just take the pen. Okay, therefore what I wanted to prove here, students, I wanted to prove that a square minus 2a plus 5i. So nothing is there means I am going to take here into I, so that this I is nothing but identity matrix. Please remember this, students, for 2 cross 2, right here identity matrix, where identity matrix will be for 2 cross 2 it is 1 0 0 1. Okay, now I'll just substitute. So just now I've calculated in the calculator. So this is equal to minus 3 minus 4 a square. I already calculated in the calculator, so I'm just substituting the values. Minus 2 times, yes students, you can just substitute the matrix A. So this is 2 into A, this is A1 minus 2 2 1 plus 5 into 1 0 0 1. So just simplify this one, solve the values. You can see this is equal to, this is minus 3 here, minus 2 into 1, so corresponding element I am going to multiply here. So this will be minus 2. So first row, first column I am taking from all the three matrices. Here I have plus 5. Similarly, you can see the next value. This is minus 4. And then this will be minus into minus plus 2 into 2, 4. Last value is plus 5 into 0 is 0. So this is 0. Similarly, next I am going to take this as 4. Minus 2 into 2 is 4. And here plus 5 into 0 is plus 0. 3 minus 3 as it is. Minus 2 into 1 is minus 2. Plus 5 into 1 is, so all corresponding elements I have taken. First row, first column, first row, second column, second row, first column, and second row, second column. All the values, if you just see, all are minus 3 plus 2 plus 1. They are all 0, 0, this is 0, this is 0, this is 0. So therefore, we say this element is 0. So this satisfies Cayley-Hamilton theorem. Is it clear, students? So like this, you can easily simplify Cayley-Hamilton theorem using the calculator. Okay, so we'll just try for the next example where we are going to take the 3 cross 3 matrix. Okay, just try this once. I will give the example here. Example. So very simple. Verify. Cayley-Hamilton theorem for E is equal to, they have given the matrix as 2 minus 1 2. Yeah, this is minus 1 2 minus 1 1 minus 1, and this is 2. Please try this example, students, using the formula what I have given. Okay, so here this is 3 cross 3 matrix. First term, what Cayley-Hamilton theorem says, it satisfies its own characteristic equation. Okay, so let us take the characteristic equation. Here characteristic equation is mod of A minus lambda I is equal to 0. So this is 3 cross 3 matrix, students. Please remember, you should not make any mistake. Very, very important. Okay, so now I will take here our equation. Yes, it satisfies the equation. This is 3 cross 3 matrix. So therefore, how we are going to take the lambda? Yes, here we are going to take the lambda cube minus s1 lambda square plus s2 lambda minus S3 is equal to 0. So this is plus minus plus minus, you are going to get, this will be lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0. You can just see this is for 3 cross 3 matrix. You have to remember this formula. Please remember this, students. Here we can see what is S1, S2 and S3. Yes, students, I will take S1 is equal to sum of the main diagonal, sum of the main diagonal elements. So please remember this, students. What is the main diagonal elements in this matrix? What is the main diagonal elements? It is 2 plus 2 plus 2 is equal to 6. So this is how we get S1 directly. This is a very shortcut. Directly you can take the S1 value without any other calculation, and this is 100% correct. Next we have sum of the minors, sum of the minors of the main diagonal elements. Okay, so we'll start with our main diagonal elements. So first term is, if I take this as 2, then the minor will be 2 minus 1 minus 1 2. If you go to the matrix, if you take this value 2, you can just look on the cursor. If you take this 2, leave this row and column, what will be minor? This is our minor. Then plus, next main diagonal is 2, again I will take this 2, again this row and column is left, so we are left with 2 2 1 2 2 2 1 2. So what will be the minor? The minor is 2 2 1. This is our minor. Next minor, you can see, students, I will take the last main diagonal element, last element, that is 2. Leave this row and column, you will get 2 minus 1 minus 1 2. So this will be 2 minus 1 minus 1 2. This is how we have to take the diagonal elements. Okay, students, so there you can simplify easily. 2 into 2, it is 4. 4 minus 1, so minus minus will become plus, and it is plus 1. You are going to get this as 3. Similarly, if you do the same calculation, you will get this as 2 and 3, which is equal to, you will get the value as 8. So S1 is, we got the value, S2 we have got the value, S3. S3 is nothing but determinant of E. Yes, friends, easily you can find the determinant using the calculator. Here we have the calculator, so I will tell you how to do in calculator. Go to mode setup, go to 6, just this, okay, then go to 1, or you can press AC so that you will get here MAT. Then go to shift, then from shift you can go to 4, that is a matrix. Then go for dimension 1, again I want matrix A. So here in this case you are going to take 3 cross 3 matrices, that is 3 cross 3 matrix is 1. Okay, so just take 3 cross 3 matrix 1. So here you are going to get all the 3 values. So just type the values. Here I will type 2 equal to, so all the values you will get, minus 1 equal to, next term is 2 equal to, next term is minus 1 equal to, then 2 equal to, minus 1 equal to, 1 equal. First you have to fit all these values in this matrix run. So I'm going to use the Casio matrix, that is, I think this is 991 number. So this calculator is my favorite. In all my videos I have used this calculator. Please prefer this type of calculator. Okay, then I have put all the values students, so I will just press EC. Then just go to shift and go to 4. There is a determinant, that is number 7. There's 7. Again go to shift 4. I will take matrix E. So I have fit the all the values in matrix E. So this is equal to 3. Here you can see directly students, I have got the value 3. So I will take the determinant is, this is very shortcut students, you will easily find it very easily you can get the answer. Now substitute all these values in our equation. So this will be lambda cube minus 6 lambda square plus 8 lambda plus 3 is equal to 0 is our characteristic equation. So when you get characteristic equations, immediately you are going to verify. To verify, we have to put lambda is equal to a. So what we will get is as a cube minus 6a square plus 8a plus 3. Here nothing is there, lambda is not there at the end of this, is a constant is there. So I am just going to take this as I is equal to 0. So we have to prove this. If you prove this is LHS is equal to RHS, that is verify Cayley Hamilton theorem. Okay. So now to prove this value, so I am going to substitute all the values here. So we are going to simplify directly in the calculator. You will get all these values students. Okay. So let us go to calculator once again. Okay, without any changes, just press EC. Already matrix E is fit in the calculator, so therefore I will go shift 4 3. Here you can see as shown, there is a button that is x raised to box is there. So just press that x raised to box. It will show you the power. So just go to 3 and then square is already there here. Instead of taking square students, you can take the cube root, that is shift. Yes, here you can get the cube root directly. Yes, here we have the answer students. So instead of doing all this, directly get the value. So it is 29 minus 28, 38 minus 22, 23 minus 28, 22 minus 22, 29. Directly will get the answer. Directly substitute the values in this, equal to, that is a cube minus 6a square plus 8a plus 3i is equal to students. Directly you put the values in this. So a cube just now we have calculated. Just put here 29 minus 28, 38 minus 22, 23 minus 28, 22 minus 22 and 29. So this is what we get the value. Now here you can see as minus 6a square is there. Okay, don't worry, go to the calculator directly. So in the calculator press AC. Now this is 6 into a square. So I'll just take 6, just press here 6 into a square is there. So I'll go to shift 4. I'll just go to shift 4. Here matrix A is already data is filled. So I'll just take this as A and then press square. So this is 6a square. Whatever the values we get, we directly write it here. So this is equal to 42 minus 36, 54 minus 30, 36 minus 36, 30 minus 30, 42. All these values I am going to substitute here. So please remember the values and substitute in this. This is 42 minus 36, 54 minus 13, 36 minus 36, 30 minus 13, and this is 42. Then plus, it is 8 times a. Don't worry students, go to calculator. We have calculator already ready. The data is fit here, so I'll just press AC. Just take here, press 8 into, again go to shift 4 3. So it is 8 into a, which is equal to, yes, here we have the direct value students. Just substitute 16 minus 8, 16 minus 8, 16 minus 8, 8 minus 16. It is already there in our calculator. Directly put it in this. So this verifies Cayley-Hamilton theorem. So 16 minus 8, 16 minus 8, 16 minus 8, 8 minus 8, 16, and remaining is our I value. So what will be this? This is a minus will be there. Please remember, plus minus plus minus. So minus 3I. So this is identity matrix with 3 cross 3. So this is 3 0 0 0 3 0 0 0 3. Yes students, now you are going to simplify corresponding elements. You please see what are the corresponding elements you will get here students in this. Directly you put it in the calculator, you will directly get here corresponding elements. Here you can see 29 minus 42 plus 16 and minus 3. So all these values you will get here 0 0 0, and this is 0 0 0. Similarly here we get 0 0 0. Therefore this is equal to 0. So this verifies our Cayley-Hamilton Cayley-Hamilton theorem. So this is how we simplify for 3 cross 3 matrix. Yes friends. So just say this as CH theorem. Is it clear students? So any doubt is there, you can ask me. Any queries are there, you can put it in my YouTube channel, Engineering Mathematics Made Easy for All. Here we can see I already made some other videos in this, and here we have learned Cayley-Hamilton theorem, how to find the characteristic equation, characteristic polynomial, and lot of more examples are there. Please subscribe to my channel, you will get more and more videos. Thank you so much. Thank you students.